Okay, so let's start with an explanation overview of buffers, because I think if we understand buffers, then the titration curves and the acid-base indicators make a little bit more sense. So remember, a buffer is a solution that resists change in pH upon the addition of a strong acid or strong base. Okay, and basically that's always going to be a conjugate acid-base pair. So we have, and they both need to be present. So we have a weak acid and its conjugate base present in the solution. So if we look at our diagram right here, we have two weak acids, HA, and two conjugate bases, A minus. The little black dot is H plus, and then the little blue and black dot are OH minus. Okay, so if I add, so let's first look at what happens when I add the strong acid to the solution. So I'm adding H plus ions straight to the solution. Now, if I were to add H plus ions to a solution that's not a buffer, immediately the pH would drop. But because I now have something that can react with the H plus ions, the pH is going to only change very slightly. So when I add this H plus ion, it's going to react with the conjugate base to form now the weak acid in solution. So the overall reaction is going to be A minus plus the H plus ions yields HA, or in solution we can also write it as H3O plus A minus yields HA and water. Okay, so the water is really also an indication that there has been some kind of neutralization that's happened. Okay, so now my solution, if I redraw it, I still have my two HAs, my two weak acid molecules, but now I have added a third weak acid. Okay, so now in solution I have a 3-to-1 ratio of weak acid to conjugate base pair. 3-to-1. Okay, and then eventually that, if I add another H plus, obviously that's going to change it to now be a 4. Now I'm going to have 4 weak acid molecules to my 0 conjugate base. So now at that point, when I add H plus, there's not going to be any A minus for the H plus to react to, so my pH is going to change dramatically. So there's a point in time which the solution can no longer resist change in pH, and then you'll see that drastic change again. Okay, but for this right now, it's still showing 3-to-1. Okay, so that's what happens if you add strong acid, and now it's a very similar reaction that happens when you add a strong base. Now the base is going to react with the weak acid and form water again and an A minus. Okay, so the hydrogen ion that's on the HA is going to now attach to the OH minus and neutralize the strong base. So now in solution, I'm going to have three conjugate bases and 1 weak acid. Okay, and again, there's no hydroxide ions floating around in solution. The hydroxide ions floating around in solution is what is going to drastically change the pH. But because it can react with the weak acid, there's going to only be a very slight change in pH. So that's where you get this idea of it resisting pH. So now I just have 1 weak acid and I have 3 conjugate base. And this overall reaction is OH minus plus HA yields A minus plus H2O. Okay, so just to, and then again, if I were to add another OH molecule to this solution, eventually I would now have no more weak acid left to react with the OH. Then at that point, adding any additional OH is going to significantly change the pH, and it's no longer a buffer. Okay. So if I just look at this example, remember buffers, and this is an AP concept that you need to make sure you understand. Buffer have large concentrations of both members of the conjugate acid-base pair. So in order to be a buffer, you have to have both the weak acid and its conjugate base in solution in a large enough concentration to actually be able to resist the change in pH. So when I add base to my acetic acid, my solution now becomes CH3OOH plus OH minus yields the weak base CH3CO minus plus H2O. Same thing if I add the acid, I now get, if I add the acid, my conjugate base is now going to react to form weak acid and water. Okay, so hopefully that helps you understand buffers a little bit more, and then the next video I'm going to explain titration curves and hopefully use this concept that we learned about with buffers to make more sense.